Hello everybody, and welcome back to another Eng 130 video tutorial. In this tutorial we're going to continue with centroids, and we're going to cover the second scenario that you can face. So remember, the first one is when they give you a curve, and when they give you a curve it looks more like a Math 100 problem than an Eng 130 problem because it involves integration, and we refer to those as continuous bodies. So the whole body is defined by one nice continuous curve. Now in real life that's very unreasonable. Actually, you'll probably never ever see it. Instead, what we usually have, especially in structural engineering, is what we call composite bodies. So the body is made up of a bunch of simplistic shapes such as squares, triangles, rectangles, even circles. And there's kind of a little secret for centroids where if we know the centroids as simple shapes, which we already do, keep in mind for distributed loads, when we found out where the loads acted, for instance, a rectangle, we knew that the load would act halfway, or the distance would be half of the length of the rectangle. That was actually the centroid. So what we can do is we can find the centroid of these very simple shapes, and then we can find the centroid of the overall structure using a relationship between the simple shapes and then the overall, composite body. And we use this in structural engineering all the time. You think about one of the most common shapes, you guys can think of an I-beam. A lot of people, instead of trying to integrate over that shape, the I shape, instead we can treat it as three rectangles, and because we know the centroid of a rectangle, find the centroid of those three little rectangles and then use a mathematical expression, which we'll cover, that'll give us the centroid of the whole I-beam itself. So it actually works out really nice. But with that being said, I think we'll just jump into it. It's actually a really nice short example because these composite bodies aren't actually that hard. There's a certain methodology to it, and we always stick to it. There's no real tricks with this one. If you guys understand what's going on in the video, which I think you will, it's very simple, you guys will be just fine and ready for the final. So let's jump into it. Alrighty, so looking at this example, it would like us to determine the location of y bar of the centroidal axis, blah blah blah. Basically all it wants is this little y bar right here. So it wants our reference axis to be this bar up here. So this is our reference axis, and it wants to find that distance y bar to the centroid of the shape. And I'm just going to make this a little bit straighter because that was real bad. So this is our axis, and it wants us to find the distance to the centroid of the shape. So it's kind of funny because it already gives you kind of where the centroid's located, but it doesn't tell you the distance. So of course we're going to have to figure out the distance. So remember before, when we had a continuous body or a curve, our formula was this: y bar is equal to the integral of y squiggle dA, all divided by the integral of dA. So that one wasn't hard to remember, and as you guys can kind of guess, the integral that we're going to, not the integral, I guess, the formula we're going to use now is actually going to look very similar. So it's going to be y bar is equal to, and this is very common, and this comes to a lot of problems, not even just centroids, but a lot of engineering problems where you can't integrate something. If something's not continuous, you can't integrate it, it's very difficult, so you have to use approximation methods, and those approximation methods rely on something called a summation, and that's what we're going to use in this case. As we see, our curve here is not continuous. We have to kind of hop on over to the approximation methods. So for this equation, it's going to be the summation of AI. So I is the shape. So if we have three shapes, I is going to be 3. And what it means is we have to find the area of all three of the simplistic shapes. AI times y squiggle I, all divided by, I guess that's kind of high, but it'll work out, the summation of AI. So if we look at these formulas and compare them, looking at the first one, we got a y squiggle, and at the bottom, we also have a y squiggle. And then we also, at the top, we have a dA and a dA, and at the bottom, we have an A and an A. So these formulas are actually identical. The only difference is one is a summation of the other. So again, like I said, before we use this formula, the whole goal of this formula is to find simple shapes within our composite shape. And with those simple shapes, we can find the centroids of each one, and then in the end find the total centroid. So the first real goal that we have to determine is what are our simple shapes. So I'm going to go through and I'm just going to highlight them in different colors. So the first one I see is very obvious. We got a giant circle right at the bottom, and I'm hoping that this program will make. I was hoping for a nice circle, but that was the opposite. So we got a circle here at the bottom. Let's see if it goes now. Oh, so that wasn't too bad. So we got a circle. Oops. Yeah. I just wanted to kind of highlight it a bit. So we got a nice circle. So hopefully you guys can kind of see that. The hardest part of these problems for the composite shapes is actually just identifying the shapes. It's actually not too bad at all. But so we got a circle. Shape number 1. Let's switch colors. It's pretty nice to see that there's a nice rectangle at the top. So something like this. Oops. Again, I just want to shade in these colors. I don't want to make the shapes go crazy. So we got shape number 2. And finally, I see another rectangle that comes across like this. So this one's kind of a vertical rectangle or something like that. So get out of there, and I'm just going to highlight this. So we see that our whole composite shape is actually made up of just 3 simple shapes, 2 rectangles and a nice circle. So here's kind of the goal of what we want to do. It's kind of like making an Excel spreadsheet. So our whole formula relies on 2 factors, just like before. We need to figure out the top and we need to figure out the bottom. So if we look at the top, we need AI and YI, and at the bottom we just need AI. So what I want to do is I want to make some sort of spreadsheet-like thing to determine all of these values. So what I'm going to do, and this is what I recommend you do for the exam, it's a kind of a foolproof way to always get the answer right. And it's a very simple process. I think when I was doing the kind of the practice solution for this, it took like 3 minutes. It's actually very, very simple. So for these kind of things, for composite shapes, you're always going to want to make a spreadsheet. And this goes for moments of inertia too, but we'll talk about that next week. So for spreadsheets, we're going to go, our first column is always going to be our shape. So we have to identify what shape we're talking about. And then our second and third column are going to be the 2 variables that are in our equation. And there's only 2. So the first one is AI. So this is the area of the shape. So this one will be in millimeters squared. And then the second one is going to be YI, or Y squiggle I. So this is going to be the distance from our axis to the centroid of the simple shapes. So if it's a distance, it's just going to have millimeters. And then the third column, which is what we need for the top of our formula, is going to be AI times Y squiggle I. So this will have units of millimeters cubed. So all we're going to go down is we're just going to go to each shape and figure out the 2 parameters, AI and YI. Then we're going to multiply them together to get our third column. So just like a nice little Excel spreadsheet. I don't know why I couldn't say that. But here's kind of the thing. I know a lot of you guys can probably do this without the spreadsheet. You can just do it all in nice one big formula. And awesome, perfect. The only reason why I'm saying this is kind of, it'll help you guys make less mistakes. Those formulas for this, it's very doable, but it gets very long in your calculator, so a mistake will likely happen there. But the second reason why I'm saying it is more so because the idea of this table or spreadsheet, it comes into play a lot for moments of inertia. And for moments of inertia, we need to know the spreadsheet very well. So it's kind of good to get your practice in now while it's still easy, and then it'll hopefully make a lot more sense later on when it gets a little bit more challenging. So we're going to start filling in the columns. So the first one that we have, our first shape, is we have a circle. So that's not bad at all. We can throw that in there. We also have a long rectangle like this. So I'm going to put this one in here as well. It really helps that we can color them in, really distinguish them from one another. And the last one is our other rectangle, but this one is vertical. So something like this. They're not to scale, but again, it doesn't really matter. We're not going to dock marks if it's not to scale. So what we can do is I'm just going to, and I'm going to finish this. So remember, we're going to end this. So this is going to be this, and then our last column we're going to talk about at the end. So all we're going to do is just come down and talk about each shape. Now, you guys are really smart. I don't have, like, I'm going to show the calculations, but you guys are smart. You guys know the areas of a rectangle, the area of a circle. You guys can just fill these in, and you guys can do it really quick because I know how smart you guys are. So bear with me while I go through all these things. So first shape that we have, so shape 1. And I'm going to put in brackets, circle, circle. I just about couldn't spell it. Oh, you guys would have laughed at me pretty good there. So for circle, we're going to need to know two things. So I'm going to draw it. So one thing that we're going to need is the area. So if we have a circle, so this is our circle. Very beautiful, very, very beautiful. So the area of the circle, so A is equal, and we all know it's just pi r squared. In case you forget, it is on your formula sheet, so don't worry too much. So pi r squared, well, we know pi is just going to be pi. And r, if we look up here, we're given r as 50 millimeters. So r times 50 squared. So we know the area of this circle is going to be equal to 2500 pi. So this is the area. So when I come up to the spreadsheet here, in the first row here, we know that the area is equal to 2500 pi. So I can input that right there. So one entry is done. But now we have to talk about what y squiggle is. Y squiggle. And what this is this is the distance from the axis that we want to the centroid of our simple shape. So we know that for a nice circle, the centroid is going to be right at the center. And if you didn't know this, this is on our formula sheet. And what we want is the distance from our axis. So if we look up here, we want that pink axis. So that's why I drew the shape, because we have our axis up here. So this is our axis. So the distance that we're looking for is going to be, and I'll do it in purple, we want this distance right here. So the distance from, we want the distance from our axis to our centroid down here. So we know that the distance from here to the top of the circle, so there to the top of the circle is going to be 15 plus 150. So this right here is going to be 15 plus 150. And we know that the distance from the top of the circle to the centroid is the same as from the top of the circle to the center of the circle is going to be the radius, which is 50. So we know that y squiggle is going to be equal to 15 plus 150 plus 50. So y squiggle is going to be equal to 215. So if we come up here, our next column, 215. And since we know AI and YI, we can multiply those two together to give us our third column, which is AI Y squiggle I. So if we do those two together, we get 1,688,606. So again, I just took 2500 pi and I multiplied that by 215 to give us that big, large number. So that's it for the circle. And the circle is roughly the hardest one. Rectangles are nice and simple. So shape 2. And what shape did we say? So I'm going to go horizontal rectangle. So for this one, it's kind of a little bit nicer because what we have is just a horizontal rectangle. Perfect, that'll work out fine. So we know that the area of this is just going to be the base times height. So if we look up at our dimensions here, we see that's 150 long and then 15 millimeters high. So we know that this is going to be 2250 millimeters squared. So we come up here, and we're just going to put 2250. Excuse me. So did you guys see how tedious this is starting to get? I'm drawing out all these shapes. I'm putting area equals base times height. When you guys have this question on your final, you can literally just draw the table and start plugging in values into the table. You don't need to go through all these simple calculations. I'm just showing you again where they come from. So again, we need y squiggle, which is going to be the distance from the axis to the centroid of the shape. So if we look at our shape right here, we know the centroid is going to be right at the center. And the axis of this is actually at the very top of the shape if we look at it. So we come across here. This is actually our axis. So our distance for y squiggle is going to be, oops, and I'll change colors just to highlight it a bit more. So this is going to be our distance right here for y squiggle. So we know that y squiggle is actually just going to be the thickness, which is 15, divided by 2, which is equal to 7.5. So we come up here, I can throw in 7.5, and since I know a and y squiggle, I can multiply them together to give us a times y squiggle I, which is 16,875. So again, that's just 2250 multiplied by 7.5. So 2 shapes done. We have 1 shape left, so I'm going to go shape 3, which is the vertical rectangle. So this one's a little bit different. So I'm going to come down here. Oops. I'll draw it, let's say right here. So we got our vertical rectangle. So the area, well, it's again very easy. It's just going to be base times height. And if we look up, its thickness is 15. Its height is also 150. So the area is actually going to be the same as the last one. So base is 15. Height's 150. So the area is going to be 2250. So area. So I'm just going to come up here into our nice table. We're going to go 2250. Come down here. The last thing that we need is y squiggle. So I'm going to draw where the axis is. And it's slightly above this shape. And we know that our centroid again is going to be right in the center. So the distance from here down to the centroid is going to be consisting of 2 things. It's going to be the distance from the axis to the shape, which is 15, and the distance from the top of the shape to the center of it, which is going to be 150 divided by 2. So when you do all that, you guys are going to get that y squiggle is going to be equal to 90. So you come up here, we can throw 90 into our table, and we're going to take 2250 and multiply it by 90 to get 202,500. So for now, our table is complete. We found AI and YI for all 3 of the shapes, and we even multiplied AI by YI together. So the next part, what we have to do is we have to look at our formula, and here's kind of the key. In the formula right here, there's a summation. So what we need to do to this spreadsheet is we're going to include a summation at the bottom, and what we're going to do is we're going to add up all of the columns to find our final sum. So looking at AI, we can go 2500 pi plus 2250 plus 2250 again, and our total area for the whole shape is going to be 12,354. Likewise, we can do the same thing for the third column, which is the AIYI. So we can go, oh my God, what is that number? 1,600,000 blah 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 plus 16,875 plus 202,500, and what we get for this one is 1,907,981. So now we have 2 numbers here, and this is exactly what we want, because if we look at our formula, it's comprised of 2 things, the top and the bottom. And now we have the top and the bottom. So we can come down here and we can say y bar is equal to the summation of AI y squiggle I, all divided by the summation of AI, and then we can just plug in our numbers. So if we look at AIYI, the summation, well, that's going to be my value that I have here in pink. So it's going to be 1907.98, and there should actually be a 1 here. I forgot to complete it. So this is going to be 1907 times 90, oh sorry, not times 91, 981, and all of this is going to be divided by the summation of AI. So if I come up here, that's my value in purple. So this is going to be the one that has the 12,000, so it's going to be 12,354. And when I enter that all in, I get 154.44 dot dot dot. So this y bar, if we look at the units, the top has units of millimeters cubed, bottom has units of millimeters squared. So when I start canceling stuff out, the cubed goes away, the millimeters squared at the bottom goes away. Our units are millimeters, and that should be expected. It's a distance. So what I can do is I can come down here and say y bar is equal to 154 millimeters. I can highlight this, and this is my final answer. Excuse me. So this is it for the example. Like I said, it's actually a nice, short, easy example. But centroids are meant to actually be easy. They're not too bad at all. But here's 2 tricks that they can do to throw you off of this. There's going to be 2 tricks, and these are all that you're going to need to know. The first is they can give you a shape that looks like this. So I'm going to put trick number 1, I guess, and this is negative area, I'll call. So let's say that they give you a nice square like this, but inside the square there's a missing circle. So the shape looks something like this. I know you guys are probably thrilled just to sit here and watch me color something in. So basically a negative area. We have a simple shape, which is a square, but then there's a circle missing from it. For this, all you have to do is you treat this the same way. You treat it as a square and you treat it as a circle, but the area of the circle is negative. So if this was our shape and we're doing our 2 things, all we have to do to account for the fact that the circle is missing is we're going to have that the area of the circle is negative. So it'll be pi r squared. You get a number, and all you have to do is tag on a little negative sign to that. So this is kind of trick number 1. And trick number 2, I'll do this in dark green. So again, trick number 1, if a shape is missing, the only thing you have to do is put a negative on the area of the shape. Trick number 2, this is kind of a really good one. They usually like to throw us in exams, and they don't usually talk about it. They won't even put it on the lab. They usually just wait for exams for this one. And this is a special axis. And I know this title probably sounds very confusing, but I'll show you exactly what I mean. So let's say that they give you a shape like this. Oops, I see what happened. So let's say that they give you a shape. Come on. Oh, that's why it's not actually creating a full square. So let's say that they could do this. They give you a nice square like this, and then they give you a circle or an oval, something like this. Excuse me. And what they do is they say that the axis they want you to find the centroid about is this one right here. So this is one thing that you guys are going to have to really pay attention for, is when our axis cuts through 2 shapes. We have some on the top of the axis and we have some on the bottom of the axis. Luckily here in this example, everything was below the axis, so it's been fine. And usually the examples they give you in class, everything is above the axis, so it's fine. But in a case like this, if we have shapes below or above the axis, we have to take that into account. So the areas of the shapes are still going to be fine. They're not going to be negative because they're both solid areas. We only make the area negative when it's missing from a shape. What we do to account for this is in our y squiggle. So for this one, if this was our x-axis, and my y squiggle for the square is this y squiggle is going to be positive. However, for this bottom axis, which I'll change colors, so down to this centroid down here, this y squiggle is negative. So again, if you have 2 shapes that are on opposite sides of the axis, The only thing you have to do to account for them is change the y squiggle. If it's below the axis, make sure y squiggle is negative. If it's above the axis, make sure y squiggle is positive. If your shape is completely above or below the axis, like it is here, you can keep it positive. However, if they didn't give us y squiggle as kind of a value, and they just gave us that axis and said, hey, this is the x-axis, that's it, I should have probably made all of these negative values because they're all below the x-axis. So just kind of one thing to keep in mind, because what that would have done is give us a negative x value, a negative y value, which means that I had to, oops, I'm on the eraser, which means I should have measured down from the axis. So it's one of those things, just be careful. These are the only two tricks that they can do. One, negative area. Again, all you have to do is make the area negative, very simple. The second one is when they give you some of the shape above and below an axis. If that's the case, just make sure that your y squiggle is adjusted accordingly. But that's basically it. So thank you guys so much for listening. This is it for centroids. Next week, we're going to talk about moments of inertia, which is very, very similar to centroids in both the continuous and the composite case. So we'll get to that. And yeah, I guess that will wrap up the course and we'll get into final review. So thank you guys all so much for listening, and I'll see you guys in the next video.